In this forklift safety course, you will learn about forklift load dynamics. This includes all factors that affect the load of your forklift, the importance of placing the load properly on your forklift, safe load capacity, load moment, center of gravity of your forklift and load, and other stability factors. The rated load capacity of a forklift only applies to the load center indicated on the data plate. If the load is not centered at the specific position, the forklift's capacity will be reduced. Loads come in all shapes and sizes, not just symmetrical boxes. The load size, position, and weight distribution critically affect the forklift's capacity and the stability of the forklift. Consider the following factors before engaging a load: weight, size, and position, the safe load capacity of your forklift, the maximum load moment, forklift balance, and stability. As the center of gravity for the load moves forward, the lifting capacity of the forklift decreases. First, let's take a look at weight, size, and position of the load. Load weight, weight distribution, size, shape, and position are all key factors affecting the stability of your forklift. Forklifts are designed to carry a capacity load at the standard load center, which is commonly 24 inches from the load backrest. If the load has an irregular shape, has an unbalanced weight distribution, or is not centered on the forks, the capacity may be reduced. While arranging a load, be aware of the following: forklift tip over, loss of steering control due to shifting weight, a falling load, or collision with other objects. It's essential you understand proper placement of loads on forks. Don't exceed the capacity of the forklift as it appears on the forklift nameplate data. If a load is oversized, irregularly shaped, or loaded incorrectly, the actual load center distance could exceed the stated load capacity center distance, causing the forklift capacity to be exceeded. Always minimize the distance from the front wheels to the load center. Load a large rectangular box widthwise across the forks of the forklift, as in placing a large rectangular load lengthwise causes the load center to shift forward further away from the front wheels. This will exceed the forklift's capacity in many situations, and lifting of the rear wheels off the ground. Place loads as close to the front wheels as possible to minimize this load center difference. Load the heaviest parts towards the mast. Position the load in a way that will shorten the load center distance. Safe load capacity practices include being able to estimate the safe load capacity with an oversized load, and use field calculations to estimate the reduced lifting capacity if manufacturer's instructions are not available. As an example, assume a forklift has a 4,000 pound capacity at a 24-inch load center. The actual load is 3,000 pounds, centered at 36 inches from the front of the face of the forks. The first thing to recognize is that the actual load center distance of 36 inches exceeds the standard load center distance of 24 inches, on which the 4,000 pound capacity is based, so the safe load capacity is actually less than 4,000 pounds. To estimate the forklift's safe load capacity at a 36-inch load center, take the rated load center, 24 inches, and divide it by the actual load center, in this case 36 inches. Then multiply this number by the stated capacity to get the new approximate safe load capacity. The equation looks like this: 24 inches divided by 36 inches times 4,000 pounds. This gives us an approximate load capacity of 2,666 pounds. In this example, a 3,000 pound load is unsafe even though the rated capacity of the forklift is 4,000 pounds. Now let's look at forklift load moment. You should understand that shifting the load center affects capacity of your forklift. When the load center distance increases, it's actually increasing something called the load moment. Load moment is equal to weight multiplied by distance. As an example, a 5,000 pound forklift rating based on a 24-inch load center means that 5,000 pounds times 24 inches equals 96,000 inch-pounds, which is a maximum load moment. For an actual load center of 36 inches, we have 96,000 inch-pounds divided by 36 inches, which equals 2,666 pounds, which in this case is the maximum safe load. In this example, moving the load center 12 inches further away reduces the maximum safe load by almost half. Now that we understand load moment, let's look at the load moment hazards. While carrying a load near the maximum allowable capacity, be aware of the following: the danger of tip over, danger of losing your load, and danger of being struck by a falling load. Safe practices include calculation of maximum allowable load moment to determine the safe load limit, minimizing the load center distance measured from the back of the forks to the center of the load, and using extra caution when handling extra heavy loads. For example, when handling a maximum load, the load should be carried at the lowest possible position, and you should accelerate slowly and evenly. Another important aspect of load stability in forklift operation is to understand the center of gravity. Understanding why forklifts tip over and why loads become unstable and fall is very important in preventing accidents. Important factors that affect a forklift's balance are center of gravity and shifting center of gravity. When considering center of gravity of the load, you should distribute the weight evenly when carrying irregular sized loads. Keep the center of gravity of the load as near to the front wheels as possible. And keep the center of gravity of the load as near to the front wheels as possible. Let's look at shifting center of gravity. Always be sure to handle loads that are within the capacity of the forklift as stated on the data plate. Don't operate a forklift if the back wheel begins to lift off the ground. Handle only stable or safely arranged loads. Exercise caution when handling off-center loads that cannot be centered. Be sure to tilt the mast forward cautiously when positioning the load onto a stack. Never travel with the load elevated. This will shift the center of gravity upward and forward, making the forklift and the load less stable. Keep the center of gravity of the load as low as possible to the ground and as close to the front wheels as possible. Carry the load at the lowest possible position, which is about 4 to 6 inches off the ground. Tilt the mast back and position the heaviest part of the load against the carriage. And be sure to travel with the mast tilted back to stabilize the load. Understanding the stability of the load and your forklift is another major concept in understanding load dynamics. Maintaining stability of a forklift is easier once you understand a few basic principles. There are many aspects of a load vehicle stability, including the stability triangle, longitudinal stability, lateral stability, and dynamic stability. This discussion focuses on sit-down, counterbalanced forklifts. Counterbalance means that the forklift is weighted in the back with a counterweight so you'll not tip over when the load is placed on the front. The counterweight is located between or behind the rear wheels and provides a weight in the back to counterbalance the weight of the load in the front. In the picture in this example, longitudinal stability is lost when the center of gravity moves too far forward. Now let's take a look at your forklift stability triangle. Forklifts have a 3-point suspension system. As long as the center of gravity remains within this stability triangle, the forklift is stable and will not tip over. The center of gravity shifts when the forklift is loaded. Lateral stability is the forklift's resistance to overturning sideways. Dynamic stability refers to the idea that the center of gravity can shift outside the stability triangle as a result of sudden starts, stops, turns, or operating on grades. The load center is the horizontal distance from the fork's vertical face to the load's center of gravity. Moment is the object's weight times the distance from the forklift backrest. In the two pictures on this slide, the top picture shows us that the forklift will not tip over as long as the combined center of gravity of the forklift and the load remains inside the stability triangle. The bottom picture shows us tip over will occur if the center of gravity shifts outside the boundaries of the forklift stability triangle. As a forklift operator, it's your job to maintain stability of your forklift and load. Keep the combined center of gravity within the stability triangle. Don't accelerate rapidly or brake suddenly. Sudden changes in direction can shift the combined center of gravity outside the vehicle's stability triangle and destabilize it. Don't make rapid turns. The combined center of gravity can shift outside the stability triangle and may cause the vehicle to tip over to the left or right. Never turn on a grade or ramp. Even a 10% grade can shift the combined center of gravity outside the stability triangle and cause the vehicle to roll over laterally. Let's take a look at the forklift on the ramp in the bottom picture. The forklift teeters and finds its balance point. As the load is added to the seesaw, the moment is increased on the right side. The loaded forklift reverses and finds a new balance point at its combined center of gravity. To properly maintain stability of your forklift, there are other operational considerations. Be sure you cross obstacles such as railroad tracks, beams, potholes at a 45-degree angle so both wheels do not elevate simultaneously. Maintain control of your vehicle at all times. Adjust your speed to match the conditions. Be aware and anticipate dangerous motions and avoid them. Consider the dynamic forces that result when a vehicle and load are put into motion. The weight's movement causes a shift in the center of gravity due to the dynamic forces created when the machine is moving, braking, cornering, lifting, tilting, and lowering loads. When determining whether a load can be safely handled, you must exercise extra caution when handling loads that are close to the forklift's rated capacity. Drivers' actions affect stability. Carry loads at the lowest possible position. Accelerate slowly and evenly, and tilt forks forward cautiously. A forklift is different than an automobile. A forklift does not drive like a car. A forklift changes shape as you raise and lower the mast. A car's shape doesn't change. A forklift with load has restricted forward visibility. A forklift has exposed moving parts. A forklift has very stiff suspension to prevent sway and bounce. A car's center of gravity changes little with any load applied. A car is not designed to carry heavy loads, and a car cannot corner as sharply as a forklift. Additionally, a car is designed for maximum forward visibility. In summary, it's your responsibility as a forklift operator to understand load changes, understand the stability and control of your forklift, understand the capacity of your forklift, and understand safe operations.